Hey everybody, so we're going to begin our first unit in Physics C, mechanics based, or sorry, calculus based, and we're going to talk about 1D motion, or just one-dimensional motion. So usually that'll be like a car going in a straight line, or something of this sort. Now it's important to keep in mind that usually, or at least all the time in 1D motion, you're going to have, obviously, one direction. So an object will either travel from left to right, or up to down. An object will not travel in a curved or parabolic shape like this. That we're going to cover those types of motions in 2D motion. Obviously, because in these types of scenarios, our object has an x component and a y component, hence the 2D. But anyways, we're going to discuss 1D motion. So at the top, you see the 5 most commonly used equations for 1D motion. So it's pretty important that you guys have these memorized if you're taking any tests in class or just the AP test as well. These will be used a lot, to say the least. So we're going to go through kind of a quick problem of 1D motion. So at this point, you should have a decent grasp on position, velocity, and acceleration, and we're going to use that during a 1D motion. So we're going to say a car cruises at some velocity. Let's call this velocity, 15 meters per second. So car is moving along at 15 meters per second. And now the driver, he's going to stop at some point. So the driver will stop, maybe 135 meters from where he started. So what acceleration, the driver stops 135 meters from the start point, So what acceleration would he need to reach a different velocity? So what acceleration, or just XL for short, is needed for the car? So the car is going to slow down or speed up for the car. Well, actually, we know it's going to slow down because we said it stop. The driver stops. So for the car to reach, we'll go 7 meters per second. And we have to specify that this is by the time the driver stops. So here's some tips when covering problems like these. You want to take a look at the problem and list out what you know. So not just underline or annotate the problem itself, but actually list it out. So what do we know? Let's identify the variables that we know. Now, before we do this, let's identify the variables that we're going to use for any 1D question. We're going to have acceleration, we're going to have our initial x position, our final x position, our initial velocity, our final velocity, and in some cases, we'll have time. So what variables do we already have? Well, we know our car's already at 15 meters per second, so we know our initial velocity, right? The velocity we're starting out with is going to be 15 meters per second. Now we know that the car wants to reach 7 meters per second, so it's going to be the velocity that we end up at, 7 meters per second. Well, what is our initial x position? We don't know where he started, but we can take our reference frame to be whatever we like. So no matter where he starts, we're going to call that position 0 meters. So, if you take a look, if we just draw a straight line here representing the car's motion, we don't know the exact location of this point. But we can just assume that at this point, x is equal to 0, because that is going to be where he starts for us. So we know that our x initial position is going to be 0, and our x final is going to be 135 because he's stopping 135 meters from the start point. So 0 meters and 135 meters. What do we not know? We don't know acceleration because we want to find that out, and we don't know time. So now that we have our variables listed out, we're going to go up to the equations and check which equation fits our needs. So going up, let's see. This equation has time, this equation has time and acceleration. Actually, this equation has time, not acceleration. This is both, so we can't use it. This would solve for something we don't want. And this equation also has both. This equation has both as well. So it looks like we'll be using this equation. So the equation, so just go ahead and write that equation down. So we're going to say v squared, you can get points on this for the AP tests, is equal to v of 0 squared, your initial velocity squared, plus 2a times x minus x of 0. Now taking a look at what we have listed out here, let's go ahead and plug in our variables. So we get 7 squared is equal to 15 squared plus 2a times, and then 135 minus 0 is just going to be 135. So now from here, it's going to be very, very simple to solve the problem. All you have to do is plug it into your calculator. And if you do that, so you have to make sure that your exponents and everything is correct. So we get 7 squared to be 49, 15 squared is 225. Now, our acceleration is going to equal to 7 squared minus 15 squared divided by 135 times 2. So plugging this into our calculator, we'll get 49 minus 225 divided by 135 times 2, which is 270, and we get negative 0.65 meters per second squared. So don't forget your units. Acceleration is in meters per second squared. Now what does this tell us? Well, we know the car is slowing down, so we know a negative acceleration is the correct answer. This is us checking our answer. We know the acceleration has to be negative because if you think back to your velocity and acceleration contrasts, our car is slowing down. And an object in motion only slows down when the velocity and acceleration are opposite signs. So we know our velocity is greater than 0 and our acceleration is less than 0. So we can confirm that our object is indeed slowing down from 15 meters per second to 7 meters per second. And this makes sense. So these are the types of problems you'll often see in 1D kinematics. This is a pretty basic one. We'll try to do some more complex examples in later videos. But if you were confused about how I did what I did, I want you guys to go back to some previous videos and make sure you understand how an object's position, velocity, and acceleration all relate. So in the next video, we'll try to go through some more harder examples and just kind of hammer the information into your mind. And just go ahead and make sure that you have these equations noted down and that you are memorizing them.